As I said at the end of the lesson video, if you are just watching this video, that is, if you skipped ahead and said, well, I'm just going to look at the homework and copy it down, and you're saying, Mr. Naylor will never know, you're right. I might never know. But the bigger question is, will you know? Will you know how to do these problems? So if you are just skipping ahead and watching this video, I caution against that, because you'll miss out on opportunity to see the building of this skill, and then of course to practice it. And now if you have practiced it, you should be watching this video to check your homework. So let's take a quick look at these homework answers. It looks like number 1 is pretty straightforward. The bases are the same, so the exponents are able to be equal, and we get x equals 3. If you look at number 2, the bases are the same, so again, it's pretty easy to say that the exponents are equal, and that means x equals 2. Now with number 3, we want to make the bases the same, but you can write 64 as 4 to the third. That means you can now say that 6x equals 3. That means you can say that the exponents would be equal. Now be careful when solving this, because you should be dividing both sides by 6, and sometimes people accidentally will just quickly say that that equals 2. But of course that doesn't equal 2, that equals 1 over 2. So you want to make sure that your answer is 1/2. Number 4, the bases are not the same, but we don't want to do something silly and say that we can try to write 27 as maybe like 9 times 3, or maybe sillier than that, 9 to the 3. Although one of these statements is true, neither of them is helpful, because you want to make the bases the same. So you have to be thinking to yourself, how can you write each of these numbers with the same base? And that answer is simple. That answer is to write them all with a base 3. Now when I write them with the base 3, that means I'll be writing the number 9 as 3 squared. Same thing with the other number 9, but now I'll write 27 as 3 to the 3. 3 to the 3. Now that all the bases are the same, we'll be able to work with our exponents. I hope that you simplify those exponents correctly by multiplying them. So we do have this step that we have to do kind of in between here. We're going to multiply and get a 2x. Now this other 3 to the third, nothing has to change, because now what we're ready to do is we're ready to say that these exponents can make an equation. Now remember, when you're multiplying, which is what we're doing right here, when you're multiplying, you add the exponents. And so if I add the exponents, I get negative 6x plus 2x, of course, is going to equal 3. And as you work down through the rest of that answer, you do get a fraction, but that's fine. It just comes out to be negative 3/4. If you look at number 5, we made the base the same by making it a 5. That is 5 squared. And when you simplify that, you're able to say that x equals negative 1. Number 6, sometimes students will be a little bothered by. Now sometimes students are bothered by number 6 because it's got a fraction exponent. But I'd rather that you focus on the base and first just figure out how can you make both the bases be the same. Well, you are able to make the 8 turn into a base 2. That is a 2 to the third, because 2 to the third equals 8. Now you are going to have to do something with these exponents. This blue circle signifies that you're going to have to multiply them. So how do you multiply 3 times 2/3? Well, maybe you want to think of it as 3 over 1 times 2/3, so that your 3's can cancel, and you're just left with 2. Now understand that 2 is the exponent, and that would have to equal this exponent. X plus 3 is going to have to equal this 2, and that's why x equals negative 1. Number 7 also has a fraction, but this time the fraction is the base. And so we want to be able to think that this 1 over 27 is going to be able to be written the same as a base 3. Now 3 is the base. That means that my exponent is going to have to be negative. So if 3 is the base, my exponent is going to have to be negative. It'll be a negative 3. Now remember, if I did too many steps there, you can always think of 1 over 27 as 1 over 3 to the third. And when it's 1 over 3 to the third, that's going to be the same as writing that as a negative exponent. Of course, the exponents have to be equal, and that's why x equals negative 1. With number 8, the bases are already the same, so we really can just jump in here and we can say that since the bases are the same, the exponents have to be the same. But I thought we'd go over this problem because you have to be aware that this is a quadratic. A quadratic is whenever you have a square. And whenever you have a square, whenever you have a quadratic, you want to set the equation equal to 0. So we subtract x from both sides, and we set this equation equal to 0 so that we can factor it. And when you factor it, you're going to be able to get two answers for x, 4 and negative 3. And for our last one here, we see once again a fraction, which maybe you just right away want to think of this as 3 to the negative 1. And when you think of it as 3 to the negative 1, you have your bases the same so that you can say something about your exponents. Now, what do you say about your exponents? You say that you can add them. And when you add them, you create a very simple equation that's going to give us x equals 1.